TS classes. In the last video, we have studied about the time response analysis of a fast order system when the input is step signal. In this video, we will study about when the input is impulse signal and ramp signal. First, we will study when the input is impulse signal. We know that this is a transform model. Gain is fast order system, that is 1 by ST. Feedback is 1. Input is R of S, which is R of T. R of T is equal to delta of T. We know that R of T is equal to delta of T. First we have to find what is R of S. Now R of S is equal to Laplace transformation of R of T, which is equal to Laplace transformation of del of T is equal to 1 is here. We know the transfer function C of S by R of S is equal to G by 1 plus GH. Here G by 1 plus GH is equal to 1 by 1 plus ST. We have studied it in the previous class. Now C of S is equal to R of S into 1 by 1 plus ST, and the value of R of S is here, that is 1. So C of S is equal to 1 into 1 by 1 plus ST, which is equal to 1 by 1 plus ST. Now we have to find what is the inverse Laplace function of C of S. Now C of T is equal to Laplace inverse of C of S, which is equal to Laplace inverse of 1 by 1 plus ST. If we simplify this 1 by 1 plus ST, we can get it that this Laplace inverse of 1 by T divided by 1 by T plus S. So Laplace inverse of 1 by T divided by 1 by T plus 1. So 1 by T is common. 1 by T equal into Laplace inverse of 1 divided by S plus 1 by T. That implies 1 by T into, here the inverse formula is e to the power of minus T by capital T, which is the C of T. Now this is the output of this transfer function, that is value is 1 by T into e to the power of minus of small t by capital T. It is C of T. Now the output is totally dependent upon time. So it is a time domain analysis when the input is impulse input, that is delta of T. Next we will go for the when the input is ramp input. Now the input is unit ramp input. So R of T here is U of T. By taking this Laplace, we get Laplace of U of T is equal to 1 by S square is here. In the previous class, the Laplace was 1 by S. Here, the Laplace is 1 by S square. Now, we know the transfer function T of S is equal to G by 1 plus GH, which is equal to 1 divided by 1 plus ST, as we have discussed previously. Now, the formula C of S by R of S is equal to T of S, which is equal to 1 by 1 plus ST. R of S, the value is 1 by S square. So C of S is equal to R of S into 1 by 1 plus ST is equal to 1 by S square into 1 by 1 plus ST, and minus ST by S square plus T square divided by 1 plus ST. If you simplify this, I can get 1 by S square minus ST by S square plus here T square divided by, if you take T, it is from common from 1 plus ST, we can get 1 by T plus S is here, which is equal to 1 by S square plus T by S plus T divided by S plus 1 by T. This is the C of S. If you get C of T, which is the Laplace inverse of C of S, which is equal to, now Laplace inverse of 1 by S square plus T by S plus T divided by S plus 1 by T. Laplace inverse of 1 by S square is equal to small t. Now Laplace inverse of T by S is equal to, T is constant, Laplace inverse of 1 by S is equal to 1. So here T is constant and Laplace inverse of 1 by S plus T is equal to e to the power of minus of small t by capital T. This is our C of t, which is the output. Here you have seen that the output is small t plus capital T plus capital T into e to the power minus t by capital T. Here all the parts are depend upon the output only, depend upon the time only. So it is the time domain analysis when the input is unit ramp input. So in this class and the previous class we have studied all the things about the first order system. In the next class we will study about the second order system. Thank you.